Hello guys, this is the chapter number 4 of the course Quantitative Aptitude and Reasoning part first. This is the concept of ratio and proportion. Viewers, ratio and proportion are the mostly asked concepts in the examinations and the tests for various posts. Ratio and proportion are everywhere and found at almost all types of examination and tests. It is asked mostly in the Public Service Commission for the post of mathematics questions. Nowadays, the mathematics lecturer test is full of question of ratio and proportion. So what is ratio and proportion and how to solve the questions related to ratio and proportion? So in this video we will discuss it. The ratio is nothing but just the comparison of two quantities, the comparison of two same quantities having same units. So for this we have to take the same unit quantities to establish a relationship in between these quantities. So ratio of two quantities represents how many times a quantity contains another quantity of the same kind. Ratio can be written in many ways. Some ways is P colon Q. This is the ratio symbol P ratio Q, or this can be written as P by Q. That is, this is the division P over Q, or can be written as P to Q. So these are the ways to represent ratios. Here in the ratio P ratio Q, P is the numerator or it's called antecedent, and Q is the denominator or called consequent. So this P is antecedent and Q is consequent, or the results of the given ratio. Okay, and actually P and Q are the terms of the ratio. Okay, the ratio 7 into 11 represents 7 over 11 with antecedent 7 and consequent 11. Okay, this is the important rule. The multiplication or division of each term of a ratio by the same non-zero number does not affect the ratio. For example, if we have a ratio 1 over 2 and if I have to multiply with 2 the numerator as well as the denominator, so we get 2 over 4. So this is again the same ratio. So multiplication or division of any given ratio with some non-zero number does not affect the given ratio. Okay, now here are compound ratios. So ratios are compounded by multiplying together the antecedents for a new antecedent and the consequence for a new consequent. For example, if we have the ratios A, B, C, D, E, F, then their compounded ratio is we have to multiply all the antecedents and multiply all the consequents. So the antecedents here are A, C, and E. So A, C, E, and the consequents are B, D, F. Okay, so we get A, C, E ratio B, D, F. Okay, if we take numbers instead of these alphabets, for example, we take 2 ratio 3, 4 ratio 5, 6 ratio 7. So their compounded ratio is 2 into 4 into 6 and 3 into 5 into 7. So we get 48 ratio 105. Okay, now we are given example number 1. We are asked to find the compounded ratio of 3 into 4, 13 into 9, 5 into 26, 15 into 12, 15 into 2. Okay, so we have to multiply all the antecedents and have to multiply all the consequents. So we get 15 over 26. Example number 2. Find the compounded ratio of 4 to 5, 8 to 9 and 12 to 13. Okay, so in order to solve this we have to multiply all the antecedents 4 into 8 into 12 and this can be divided by 5 into 9 into 13, so we get 128 over 195. Okay, there are some important formulas. If we have a ratio a b, then its duplicate ratio is a square into b square, and its subduplicate ratio is square root a into square root b. Its triplicate ratio is a cube into b cube, and its subtriplicate ratio is a power 1 over 3 ratio b power 1 over 3. Okay, now what are inverse ratios? If a into b is the given ratio, then 1 over a ratio 1 over b, or b ratio a, is called its inverse or reciprocal ratio. So if we divide the given ratio by 1, so the new ratio is called the inverse or reciprocal ratio. And this can also be, we can also change their positions to find its inverse or a reciprocal ratio. Okay. Now example 3, you are asked to find three numbers in the ratio 1, 2, 3, so that the sum of their squares is equal to 224. So we have to find out three numbers in this ratio 1, 2, 3. That is, the new numbers will be at this ratio 1 and to the ratio 2 and to the ratio 3, and their squares, sum of their squares will be 224. So let the numbers are 1x, 2x and 3x, the new numbers, because there are some multiples of that numbers. So for that I write here x with all of these. So x is some non-zero multiple of these numbers. So now take square of x, these terms, and add them, and this will be equal to 224. So x square plus 2x whole square plus 3x whole square equals to 224. Okay, x square is common. We get 1, 2 2s are 4, 3 3s are 9. So 1 plus 4 plus 9 gives us 14. So x square is equal to 224 over 14. That is, x square is equal to 16, and then x is equal to 4. So the required numbers are x is equal to 4, and then 2x is 2 4s are 8, and 3x is 3 4s are 12. So the required numbers are 4, 8 and 12. There is another important rule. If the ratio between the first and the second quantities, that is AB, and the ratio between second and third quantities, that is CD, then the ratio among the first, the second and the third quantities is given by AC ratio BC ratio BD. Okay, A ratio B, then AC, BC and DC. If we have AB, BC and CD, if we have ratio of this type, A ratio B, B ratio C and C ratio D, then the result will be AC ratio BC ratio CD. Okay, the sum of three numbers is 138. If the ratio between the first and the second is 2 3, and that between the second and the third is be 5 ratio 7, find the second number. Okay, so we are given that there are three numbers whose sum is 138, and ratio between the first and the second is 2 3, and the second and third is 5 7, and we have to ask to find out the second number. So there are the required three numbers are A, B, C. So the ratio between the first two, A ratio B, is 2 3, and the BC is 5 7. Okay, now combining these ratios, A ratio B ratio C, so we know that A ratio B ratio C is equal to AC ratio BC ratio BD. Okay, okay, so we get 10 ratio 15 ratio 21. Now the second number is 15 over 10 plus 15 plus 21 multiplied by 138, which gives us 15 over 46 into 138, which results 45. Okay, in example number 5, we are given that ratio of money with Arun and Sunil is 3 ratio 4, and that with Sunil and Suresh is 3 ratio 7. If money with Sunil is 120, how much money does Suresh have? So there are three names: Arun, Sunil, and Suresh, and the ratios are given in between them is 3 ratio 4, 3 ratio 7, 9, 3 ratio 7. Okay, so the new ratios will be 9, 12, and 28. Now the ratio of money with Arun, Sunil, and Suresh is 9, 12, and 28. So money with Sunil is 12 parts, which gets 120. Therefore, money with Suresh 28 parts gives us 280. Okay, there is a theorem. The first and second quantities are in the ratio AB. The second and third are in the ratio CD, and the third and fourth quantities are in the ratio EF. Then the ratio among the first, second, third, and fourth quantities is given by ACE ratio, BCE ratio, BDE ratio, BDF. That is, we are given A ratio B, C ratio D, E ratio F. So their combined ratio is ACE, then BCE, then BDE, and then is BDF. Okay, so this is easy to memorize it. Okay, if A ratio B is 3, 4, B ratio C is 8, 10, and C ratio D is 15, 17, then find out A ratio B ratio C ratio D. Okay, so A ratio B, B ratio C, C ratio D is actually ABC, the first multiply 3 at 15, then is BBC, this is 4 at 15, and BCC 4 at 10, 15, and then BCD is 4, 10, 17. So after multiplication we get, and simplification, we get 9 ratio 12 ratio 15 ratio 17. Okay, 960 is divided among 4 men, 5 women, and 8 boys, such that the share of a man, a woman, and a boy may be in the ratio of 5 ratio 5, 4 ratio 3. What is the share of a woman? The ratio of share among 4 men, 5 women, and 8 boys is 4 into 5, 5 into 4, and 8 into 3. 4 into 5, 5 into 4, and 8 into 3. So we get 20, 20, and 24. Therefore, share the 5 women is 20 over 20 plus 20 plus 4, 24 multiplied by 960, which gives us 300. So share a single woman is 300 over 5. So we get 60. Now what is proportion? So equality of two ratios is called the proportions. If we have A ratio B and C ratio D, and if these are equal, so this is called, they are in proportion. They are said to be in proportion. We can write it A by B is equal to C by D. If any four quantities are in proportion, the product of the extreme is equal to the product of the mean. That is, A ratio B equals to C ratio D equals AD is equal to BC. Three quantities are said to be in continued proportion when the ratio of the first to the second is equal to the ratio of the second to the third. The second quantity is called the mean proportional between the first and the third quantity is called the third proportional to the first and second. For example, 16, 12 and 9 are in continued proportion for 16 ratio 12 proportion 12 ratio 9. Hence 12 is the mean proportional between 16 and 9 is third proportional to 16 and 12. Okay, find out the mean proportional between 6 and 96. So let x be the required mean proportional. Then 6 ratio x equals to x ratio 96. So 6 by x is equal to x by 96. So we get x is equal to 24. So x is equal to 24 is the mean proportional between 6 and 96. Find the third proportional to 18 and 24. So let the third proportional be x, then 18, 24 and x are in proportion. So we get x is equal to 32. Find the fourth proportional to 16, 28 and 36. So let x be the fourth proportional, then product extreme is equal to product of mean. So we get that. Okay, now there are two types of the proportion, main two types, direct proportion and inverse proportion. So in direct proportion, we mean the proportion by which the value of one variable varies directly as the value of another variable. If 3 books cost 18, then what will be the cost of 21 books? So if the number of books are increased, the cost will be increased also. So this is the example of direct proportion. So 3 books cost 18, so 21 books cost x. So 3 by 21 is equal to 18 by x. So x is equal to 21 into 18 by 3. Okay, inverse proportion, the proportion by which the value of one variable varies inversely as another variable. If 12 men can do a certain work in 25 days, in how many days the same work will be completed by 10 men? If 12 men completed the work in 25 days, so when we reduce the number of men, so the number of days will be increased. So this is the example of inverse proportion. Okay, so in this example we can write 1 over 12 ratio 1 over 10 equals to 25 ratio x, because the inverse ratio of a number of men is equal to the ratio of corresponding number of days. So 10 ratio 12 equals to 25 ratio x. For the required number of days is 12 into 25 over 10, which is 30. Okay, to find the fourth proportion when the other three are given is called the simple proportion. If a, b and c are given quantity, then you have to find the fourth quantity x. So multiplication of mean by first term. If a and b are same kind and a greater than b, then a over b is equal to c over x, from which x can be calculated. Okay, if 96 mangoes can be bought for 228, how many can be bought by 48? So if we reduce the number of rupees or the number of amount, so less mangoes can be bought by that amount. So this is the example of direct proportion. So 228 ratio 48 equals to 96 into x, so x is equal to 16. If 8 men can do a piece of work in 25 days, working 8 hours per day, how many men will do the same work for 10 days, working for 5 hours? Okay, this is a little bit complicated problem, so let's have a full attention to this question. Let the required number of men be x. As the number of days is less, the number of men will be more. Less working hours, more men. So this is example of inverse proportion. Now we are given three things: days, hours and work. So in 10 days, 5 hour work, we are required 8 men, and for 25 days 8 hour work we required x men. Therefore x is equal to third term into multiplication of means by multiplication of first terms. So x is equal to 8 into 25 into 8 into 1, divided by 10 into 5 into 1, so we get 16 men. Okay, example number 15. Let's try this by yourself. Proportional division. Proportion may be applied to divide a given quantity into parts which are proportional to the given number. This term is the proportional division. So if divide 1848 into 3 shares proportional to 3, 4 and 5. So first of all we have to add the ratio 3, 4, 5. It gives us 12. Then to find out the first share, so uh, we have to find 3 by 12 into 1848. We get 462. This is similar for 616 for the second, and for third we have 770. Okay, the remaining examples are left for you. Try it by yourself. These are not too much tedious and easy examples. So this is all about ratio and proportion, and I hope you people learn and enjoy this session, and this is very beneficial for to have to prepare for the test. Thanks a lot for